Hello and welcome to Easy Math. In today's lesson, we're going to look at forming linear inequalities. And this will be the first lesson on a series of lessons about the topic linear programming. In subsequent lessons, we're going to look at solution of linear inequalities and again optimization. Let's begin with the first one, forming linear inequalities. As we begin with that first objective there, I find it necessary for me to just mention by passing some certain concepts that are necessary for us to try and form inequalities from given practical questions or problems. Students at this point also are supposed to be acquainted with operations of inequalities. And I'm not going to go into that, but let me just mention the following. We're going to see some certain expressions which we are supposed to represent with some inequality symbols, and this could be the following. The first one is we are going to meet an expression like less than. The expression less than will be represented by this symbol, and if we are talking less than, say 7, it means on the number line we have the 0.0 and the 0.7, and the inequality will mean this kind of a thing. That is, we are looking for numbers that are less than 7. That means we are going to look for numbers that are to the left of the 0.7. The 0.7 is not one of them, therefore I have not shaded this circle. So it begins anywhere to the left of 7 but not at the 0.7 itself. We are possibly also going to see an expression like this, less than or equal to. So the symbol is this one, and if we're talking about less than or equal to 2, we're going to have the 0.2 and 0 in the number line. This time around, we're going to begin at 2 and go anywhere on the left, to the left of 2, up to negative infinity. Remember, for the first one here, less than 7, the integral values are 6, 5, 4, 3, 2. We don't have 7 included, but for this one here, the integral values are 2, 1, 0, negative 1, and then the number in that direction. That is to the left of 2. We could also get the inequality, the expression greater than, which is going to be this symbol here. And if we're talking about greater than 10, it means on the number line we have the 0.0 and 10. And we're talking about numbers which are strictly bigger than 10. We don't have 10 included. The integral numbers or integral values include 11, 12, 13, and all that. We don't have 10 included. If we find greater than or equal to, the symbol will be that one. It's greater than or equal to. And that means if we are talking about greater than or equal to 5, we have 0 and 5 on the number line. We're talking about numbers that are bigger than 5 or equal to 5. So the integral values are 5, 6, 7, and all that. We have 5 included. If we find the expression at most, the symbol will be less than or equal to symbol, this one. And if we're talking about most 3, it means we have the 0.0 or 3, and therefore we begin at 3 and go anywhere to the left. So the integral numbers are 3, 2, 1, and all that. If we find the expression at least, it means we're talking about greater than or equal to. And so we're talking about at least 12. It means we have on the number line the number 12 or anything bigger than that, because we're saying at least. That means 12 is the least we are going to, and anything bigger than 12 is included. So we have the integral values 12, 13, 14, and all that. If you have expression not more than, it is the same as at most, is the same as less than or equal to. And so if you're talking about not more than 8, it means we have 8 or less than 8. So we have the 0.0 and 8 on the number line, and we have 8 and any value on the left, to the left of 8. That is 8, 7, 6, 5. Those ones are the integral values. Again, we have not less than. It is similar to at most. Sorry. It's similar to at least. It's also similar to greater than or equal to. Not less than 1 will therefore mean we have 1 and 0 on the number line, and we have 1 or anything to the right of 1. So we have the integral values is 1, 2, 3, any number that's bigger than 1. In excess of will mean greater than. That means in excess of 4 we have the 0.0 and 4 on the number line, and so we're talking about anything bigger than 4. 4 is not included. So the point I'm trying to stress here is, please understand, when the given number is included and when it's not. When you have these symbols, this one and this one and the last one, the number we're talking about is not included. But in all times, when you have the equal to sign, that's less than or equal to, greater than or equal to, and of course these others, it means the number we have mentioned is part of that. So check out for that. Every time, please ensure you understand the expression, what it means, and use the appropriate symbol. Let's go to actual examples. Now, in this particular part, we're going to look at 4 examples where we're going to form linear inequalities given life problems. And so we have the first one there. We have a question. Steven's salary is twice as much as his wife's. The wife's salary is in excess of 4,000 shillings. The sum of their month's salary is not more than 16,000. If the wife's salary is B shillings, form all inequalities in B to represent the information. Well, we are told wife's salary is B, so we have wife's salary is B shillings. That's an equation, not an inequality. But it also Steven's salary is twice as much. That means also we have another equation. Steven's is 2B shillings. We also told that the wife's salary is in excess of 4,000. That means if it is in excess of 4,000, it means it's bigger than 4,000. So we have the inequality greater than 4,000. And that forms the first inequality. The other thing is we are told the sum of their salaries is not more than 16,000. That means it can be 16,000 or 15,000 or 14,000, so long as it's either 16 or less than 16. Therefore, the sum of their salaries is less than or equal to 16,000. So we're going to have B plus 2B, which is the sum of their salaries, is less than 16,000. Simplifying that, you get 3B is less than or equal to 16,000. That becomes the last inequality. Another question. Told Juma is 2 centimeters taller, but 3 kilograms lighter than Kundu. The sum of their heights is not less than 240 centimeters, and the sum of their weight is less than 150 kilograms. So if Kundu is X centimeters tall and weighs Y kilograms, form all inequalities in X and Y to represent the information. Again, we begin with a statement that Kundu is X centimeters tall and Y kilograms in height, in weight, and therefore that's information there. We are told that Juma is 2 centimeters taller. That means we have an equation, not inequality, that Juma is X plus 2. Since it's just 2 centimeters bigger than this, so we have X plus 2 centimeters. And the weight, we are told Juma is 3 kilograms lighter than Kundu, so we have his weight is Y minus 3. So that it's 3 kilograms less than that of Kundu. Having thus said, we now go to the next part. The sum of their heights, it is X plus X plus 2. That is X plus X plus 2. We thought the sum of the heights is not less than. Not less than means we're going to, first of all, add these ones and simplify, get 2X plus 2. And then we say that that figure is not less than, means it could be bigger than or even equal to 240 centimeters. And we simplify that. We get 2X is greater than 238. You just took the 2 the other side. And then simplify, get X is greater than or equal to 119 centimeters. That's the sum of the height. We go forward to the weight. So their weight, the sum of their weight is Y plus Y minus 3. This is the weight for one person, this weight for the other. So just add and simplify, you get 2Y minus 3. But we are told their sum of their weight is less than 150. What does that mean? It could be 150, 149, 140, 130, and all that. Therefore, we're going to say this sum here is less than, strictly less than 150. It's not equal to 150, it's strictly less than that. And therefore, we're going to have 2y minus 3 is less than 150. And simplifying that, you get 2y is less than 153, because I just took 3 the other side. Then divide by 2, you get y is greater than, less than 76.5 kilograms. Let me also say that y is also greater than 0. We assume that the weight of Kundu is not 0. So Kundu must have some weight. That means y is greater than 0. You are probably wondering, why don't we have x is greater than 0? The reason is this expression, this inequality here, overshadows x is greater than 0. It already implies that, in other words. Let's go to the next question. The sum of two integers a and b is less than 5 times their difference. The product is not less than 17. If A is greater than B, form all inequalities represent the situation. Therefore, we say the following. First of all, if A is greater than B, then we have an obvious inequality. A is greater than B, that one. The next thing is the sum of the integers A and B is less than 5. So 5 times the difference. So I say the sum is A plus B, obviously A plus B. We know that that is less than 5 times their difference. 5 times their difference. A is bigger, so I just wrote A minus B. And so we have an inequality there. It needs to be simplified though. And so open the brackets, you get it that way. It's always good that when you're operating inequalities, make them as positive as possible. So I'm going to take the 5b, the other side, to avoid getting a negative figure at the end of the day. So I will have 5b plus b less than 5a minus a. And simplifying that, you get 6b is less than 4a, and therefore 3b is less than 2a. Now we go on. Their product. We're told the product is not less than 17. Well, the product is a times b, which is ab. We're told it's not less than 17, so it could be bigger than 17 or even equal to 17. Therefore, it's bigger than or equal to that, and that's the second inequality. Do we have another? I don't think we have another. So we have those 3 inequalities. The last question. A factory produces at most 400 items in a day. The non-defective items sell at 100 shillings each, while the defective ones are sold at a discount of 40%. So giving a day's sales of at least 30,000 shillings. Sorry, that's how it should finish there. Even a day, X non-defective and 1 defective items are sold, form all inequalities to represent the information. Well, we begin this way. What is the number of items? We are told a factory produces at most 400. That means the sum of the defective and non-defective should be 400 or less. So we have it that way, and therefore that's the first inequality. X plus y is less than or equal to 400. Again, their sales. Now we're told that the non-defective items sell at 100. That means if we had 10 non-defective, the revenue or income that will be generated from selling those 10 non-defective will be 10 times 100, which is 1,000. And therefore we can actually say that, therefore the income that comes from selling the non-defective is X. That's the number of the ones sold times the value of each. And therefore that's going to be 100x. Therefore, again, the income that's generated by selling the defective ones is going to be y times the value of selling one, which is 100 minus 40, which is 60, and therefore it's 60y. We can also say total sales will be 100x plus 60y. This is 100 times each. Sorry, 100 is the value, the how we sell one item, and x is the number of those items sold, the non-defective ones. This is how we sell one defective item, and all of them are y. But we are told that they give a day's sales of at least 30,000. That means this figure here could be 30,000 or 31,000 or 32. That means it's equal to or greater than. And so we have it that way, and we go on to simplify. Have 100x plus 60y greater than equal to 30,000. Divide all through by 20, you get this figure here. And that becomes the inequality that we're targeting to get. 5x plus 3y is greater than or equal to 1,500. Having that said, let me say that we assume this factory produces some non-defective and also some defective. So we say that we have the defective, they are bigger than 0, and the non-defective are also bigger than 0. And these are called 2 obvious inequalities, and maybe we'll always need to always put them depending on certain circumstances. The same way we put for this particular case where we said y is greater than 0. Having that said, we have come to the end of my first lesson on linear programming. Check out the I think 2 or 3 other lessons that will be coming in a short while. Thank you.